In this video, we're going to focus on the lower right-hand corner of our mole roadmap. We're going to look at the conversion of moles to particles and particles back to moles. You can see that these two calculations both involve the utilization of Avogadro's number. And before we go into sample and practice calculations, let's talk about this term particles. Particles is a bit of a general term. We want to get a little more specific when we make these calculations. So if I'm talking about a chemical element, I am in fact talking about a particle that we would call the atom. If, on the other hand, I'm working with covalently bonded compounds like sulfur dioxide, a molecular compound, or hydrogen chloride, and if hydrogen chloride were dissolved in water, it would be hydrochloric acid. What I'm talking about here are molecules. So if something is covalently bonded, and the best way to determine that it's covalently bonded would be that it probably consists of two nonmetals like sulfur dioxide and hydrogen chloride. If that's the case, then I'm talking about molecules. And finally, a particle known as the formula unit is used to describe ionically bonded compounds like sodium chloride and calcium sulfate. How do I know that something is bonded ionically? Well, it's probably going to consist of a metal and a nonmetal. And for our purposes, polyatomic ions are considered to be nonmetal. So calcium's my metal here. The sulfate polyatomic ion would be my nonmetal. So that's going to be ionically bonded. And when we're dealing with something that is ionically bonded, we talk about it in formula units. So to begin with, we're going to take a look at converting from moles to particles, and that's going to utilize 6.02 times 10 to the 23rd of those particles over 1 mole. So let's begin by taking a look at some sample problems. Here's our first mole to particle sample problem. How many atoms are there in 1.9 moles of aluminum? Very simple, very straightforward. We've got 1.9 moles of aluminum. Well, how many atoms are there in a mole of aluminum? There are 6.02 times 10 to the 23rd atoms. Specifically, it would be aluminum atoms in 1 mole of aluminum. And you can see by setting it up this way, what's going to happen is our moles of aluminum are going to cancel. And if I know how to use my calculator correctly, I'm going to get an answer that looks like this on my calculator. 1.1438 times 10 to the 24th atoms of aluminum. All that remains now is for me to consider the significant digits or significant figures issue. 1.9, that's two significant figures, so if I want to be just perfect, what I would call this is 1.1 times 10 to the 24th atoms of aluminum. And that concludes our first sample problem. Mole to particle sample problem number 2. How many formula units are there in 0.35 moles of silver nitrate? Before we even solve the problem, what I want to make you aware of is anytime we're going from moles to particles, or for that matter, particles back to moles, we don't need to calculate a formula mass. The only thing we need in these conversions, these calculations, are Avogadro's number. So I'm going to start with my 0.35 moles of silver nitrate. And it makes no difference that in this particular case I'm asking for formula units. How many formula units are there in a mole of silver nitrate? Well, the answer is still going to be 6.02 times 10 to the 23rd formula units. And I'm going to abbreviate slightly here, formula units. You're going to be allowed to abbreviate even more drastically when you do your homework. We'll talk about that in class. However, 1 mole of silver nitrate goes down here in the denominator, and running out of space here, so let's just skip down a line. 2.107 times 10 to the 23rd formula units is what I get on my calculator. As always, let's consider significant figures. 0.35 is two significant figures, so I'm going to take this, and to be just precise as can be, I'm going to go 2.1 times 10 to the 23rd formula units of silver nitrate. Remember, when in doubt, go with three significant figures. If that were the case, if you wanted to do that on this particular problem, you would simply call this 2.11 times 10 to the 23rd formula units of silver nitrate. Okay, that's about all we can do when it comes to sample problems for mole to particle conversions. So let's take a look now at your two practice problems. Here are two mole to particle practice problems that make use of the exact same technique we just saw in our sample problems. Number one, convert 9.23 times 10 to the minus 1 moles of lead-2 bromide to formula units. It's asked for in formula units. That's not something you're allowed to change, so make sure you express your answer in formula units. Of course, there's the correct answer in red. Number two, convert 1.85 moles of chlorine gas to molecules of chlorine gas. Make sure you express your answer in molecules, and be mindful of the fact that, as we said previously, in these calculations, mole to particle and particle back to mole, there's no need to calculate any kind of formula or molecular mass. Good luck. Okay, having taken care of mole to particle calculations, let's now take a quick look at particle back to mole calculations. And this time you'll notice what that involves is the use of the unity fraction 1 mole over 6.02 times 10 to the 23rd of the appropriate particle type. So here's a couple of sample problems involving this. Okay, now we're going to reverse the process. We're going to go particle back to mole. So here's sample problem number one. How many moles are there in 8.23 times 10 to the 24th molecules of water? So let's put down our 8.23 times 10 to the 24th molecules of water. And I'm going to have to ask you not to abbreviate molecules, because if you do that, it's going to look an awful lot like moles. So don't do that. Fortunately, you're going to have to write out the entire word. Okay? How many molecules are there in a mole of water? Well, there are 6.02 times 10 to the 23rd molecules. I'm going to put that in our denominator so that it cancels out. And that's going to be 1 mole of water up here. And for the sake of space, I'm going to drop down. And what it's going to equal is 1.367 times 10 to the first moles of water. Now, a couple of things here. Let's make sure that we express all our answers from this point forward in scientific notation, and I've done that here. The next consideration is significant figures. 8.23, that is 3 significant figures, so let's make sure our answer contains 3 significant figures, and let's go with 1.37 times 10 to the first, because that would be proper rounding, and that of course is moles of water. And you can see the only thing we've done here between our previous samples and practice is basically invert or flip our unity fraction. Let's move on to sample problem number 2 now. Okay, here's sample problem number 2 for particle to mole conversions. How many moles are there in 3.96 times 10 to the 27 atoms of cadmium? So let's bring down our 3.96 times 10 to the 27th atoms of cadmium. Why atoms? Because cadmium is an element on the periodic table. How many atoms are there in a mole of cadmium? Well, same answer as always. There are 6.02 times 10 to the 23rd atoms of cadmium, and that constitutes 1 mole of cadmium. And let's see, our calculator says 6.578. 6.578 times 10 to the third moles, over 6,000 moles of cadmium. Okay, we've expressed our answer in scientific notation. What about significant figures? And once again, 3.96, well, that's three significant figures. So let's express our answer as 6.5, that's a 5, 8 times 10 to the third moles of cadmium. And remember, when in doubt, just go with three significant figures. I go through this process each time to show you exactly how I'm arriving at the answers I am, but what it all boils down to, for safety's sake, go with three significant figures. Well, that wraps up our sample problems. Let's move on to our second set of practice problems. Here are the two highly anticipated particle to mole practice problems. Number one, how many moles of sulfur dioxide are 4.5 times 10 to the 24th molecules? Answer given to you there in red. Number two, how many moles are in 5.546 times 10 to the 37th formula units of zinc phosphate? Give those a shot and good luck.
With me, it's here. Without me, with me, without me.